Good evening everybody, myself Acharya Vishvendra. Today I'll discuss a worksheet on junction diodes. So the first question here is how junction diode is made. So for making junction diode, what we do is we take a p-type silicon wafer, mix it with n-type, and because of that a p-n junction is formed, and hence we can use this mechanism to form the junction diode. Question number 2 is symbol of the junction diode. So this is a symbol, this is for p side, this is n side, and arrow shows direction of flow of conventional current. If current flows in this direction, that means the diode is forward biased, and if current flows in the opposite direction, that means current is reverse biased. The diode is reverse biased here. Now is biasing of diode, so it's either forward bias or the reverse biased. Fourth question is forward biasing. So a diode is said to be forward biased when P side is connected to the positive and N side to the negative terminal as shown over here. And ideally diode offers very little resistance in forward biasing, ideally 0 ohm resistance. So it behaves as ideal conductor or pure conductor if the diode is ideal and it offers very low resistance or ideally 0 ohm resistance. Then is reverse biasing. So the diode is said to be connected in reverse if P is connected to the negative and N side to the positive terminal, and the diode offers very high resistance in reverse biasing, ideally infinite resistance, so it behaves as an open circuit. Now here is a question. There are two diodes D1 D2 and a battery is connected. Now the first question is which diode is forward biased. So you can see over here that in D1 direction of current is in direction of conventional direction of current, so D1 is forward biased, whereas in D2 current is flowing to the right, and the direction of current, conventional current in D2 is to the left, so these are opposite, so D2 is reverse biased. So forward bias is D1 and reverse bias is D2. Then is the question, what is R equivalent? So as we said earlier, D1 will behave as a conductor, so D2 as an open circuit, so there will be no current which will flow in this branch, so this resistance will have no use. So the net resistance will be 10 ohm plus 30 ohm, which counts to be 40 ohm here. Then is current in the circuit. The current is V divided by R equivalent. Voltage here is 50 volt and R equivalent is 40 ohm, so that gives us 5 by 4 ampere. Then is I1. So as we can see over here that I1 will be 0 and D2 will offer infinite resistance, so I1 will be 0 and full current will flow through I2, that means 5 by 4 ampere. Then is power supplied by the battery. So power supply, we can say that I square into R equivalent. I here is 5 by 4 whole square, R equivalent is 40, so that will give us 25 by 16 into 40. After simplification we get 62.5 watt. Then 13th question is IV characteristic of the diode. So IV characteristic is like this. Initially current is 0, and then if the voltage reaches to the threshold it increases substantially, and in the reverse bias it undergoes this reverse breakdown at a certain voltage. So this is ideal characteristic of PN junction diode. Then is circuit diagram for junction diode as half wave rectifier. So suppose you apply this input voltage. So in half wave rectifier, half of the circuit is rectified, so you get the output only for the half cycle, just like this. So this is the transformer, this is input power is applied over here, this is the diode, and this is the load resistance, and output is taken over here. So if input is like this, so output will be like this, and there will be no power during the negative cycle, so that will be the case. Then is junction diode as a full wave rectifier. So in full wave rectifier we use two diodes D1 and D2, and we use a center tap transformer which is tapped from the center, and output is taken over this resistance. So what will happen is during the first cycle D1 is forward bias, so it will conduct, but D2 will be reverse bias, so it will not conduct. While in the negative cycle D1 will be reverse biased and D2 will be forward biased. So in each cycle one of the diode is forward biased, so it will conduct, hence we will get output in both the cycles. So if input is like this, we get output like this, so we get an output, and obviously the frequency of the output is double of that of input over here in the full wave rectifier. Now is the next question is about frequency of output in half wave rectifier. So it is the same, as you can see over here that it's repeating after the same time. The frequency of input and output is same. But in case of full wave rectifier, its time period is half, so frequency will be double. That's a very standard concept. It has been asked many a times in competitive exams. Next is what is Zener diode. So Zener is a special purpose diode which is used as a voltage regulator, and it is used in the reverse bias so that current can be made constant, and voltage can be made constant. So it's made used as a voltage regulator to manage the voltage when it is fluctuating. So it's just a symbol like this. Then is how Zener diode is made. So for making Zener diode, we use the concept of thin depletion layer and high doping. These are needed so that there is a very high electric field in the reverse bias, and it's operated in the reverse bias so that a constant voltage can be made in spite of change in current. Next question is what is LED? So LED is called the light emitting diode. You must have seen that in the mobile charger or in many cameras. So that is use of it. Next is what is solar cell? So solar cell is a device which converts light into electricity. Then is what is photodiode? So photodiode is basically used to detect light signals. So it works on the same principle as that of solar cell. So it's a device used to detect optical signals. The next is why Zener diode is used in reverse bias. Obviously to keep the voltage as constant. So this is the worksheet based on junction diode. It contains all the basic concepts, basic terms, and the basic manipulation based questions, which forms the basis of higher critical order questions which are asked in competitive exams like NEET, JEE Main and JEE Advanced. In case of any doubt, you can ask in the comment section. Thank you and have a nice day.